Okay, so hi, welcome back. So in the last video, we introduced the concept of the sampling distribution of p-hat. Let's get into a couple specific examples. So for example, let's suppose we go to a college where 62% of the students, and I mean all students, of the students have a part-time job. And so what we're saying here is that pretend that we know P is equal to 0.62. And we're going to go to this population, this world. So let's suppose we take a random sample of n is equal to 150 students. And we compute p-hat. So the question that I'm going to ask is, what should happen? What, here, I'll put it out here. What values of p-hat are within reason? And we'll state it another way, that is, what does the sampling distribution for p-hat look like? And to answer this question, we're going to have to address those three issues. First, will it be a normal distribution? What will be the mean? What will be the standard deviation? So I'm just going to do this as a lettered list here, then I'm going to erase this, and we'll look at the details in a moment. So we've got to decide, are we going to have a normal distribution? We're going to have to ask, what's the mean? And we're going to have to ask, what's the standard deviation? And once we have those three ingredients, then we're going to draw a detailed picture. All right, so here's where I'm going. So let's start with whether it will be normal or not. So the first thing is, and again, I'll do this as a lettered list. Will p-hat have a normal distribution? And as I just showed in the last video, we have to check two things. We have to look at n times p, and that's going to be n is 150, p is 0.62. I'm going to grab a calculator here. I can't do this stuff in my head. So 150 times 0.62 is 93. And that is certainly greater than 10, so we're good to go there. But we also have to check the other condition. We have to look at n times q, which is 150 times. Now make sure that this is clear. If p is 62%, and that's the percentage that have a part-time job, what's q It's 0.38. So if 62% have a part-time job, 38% don't, these two percentages or proportions have to add up to 1. Let's run this calculation. 150 times 0.38, I get 57. And that is also greater than 10. So everything's cool there. Yes, we will have a normal distribution. Which is good, because if we have a normal distribution, then there's work that we can do. If the answer here comes out to be no, we can't really do too much with it. We'll talk about that later. All right, now, what about the mean / expected value of p hat? And again, don't overthink this. Mu sub p hat, or the expected value of p hat, is simply the same as the population proportion, which in this case is 62%. So it's going to be 0.62. And then the standard deviation of p hat, well, we had that formula, that's going to be sigma sub p hat, and we said that's the square root of p times q divided by n. So that's going to be the square root of p, which is 0.62, times q, which is 0.38, divided by our sample size, which is 150. And I'm going to run this through a calculator. Oh, but I want to mention something here, and this is actually really important. I'm glad I'm not forgetting this. Proportions and percentages are the same. And so when we see a proportion of 0.62, the normal person in us wants to say, that's 62%. But if we're going to do computations with these numbers, they have to remain as decimals. So when I go and I run this formula right here, I have to keep those as decimals, otherwise it's not going to work out. All right, so let me type this in. So we've got 0.62 times 0.38 divided by 150, which is our sample size. So this is just really close to 0.04. So I'm going to say that this is approximately 0.04. A lot of times people ask about, well, where do we round off? We'll talk about that later. So, it's important, but we'll talk about it later. So we know it's going to be a normal distribution. Here's our expected value, or our mean, and here's our standard deviation. As I just said a moment ago, we've got to keep these as decimals if we're going to do computations with them. But it's not against the rules to see that as 62% and that as 4%. So the next thing that I want to do, ultimately we were asking, what does the probability distribution or the sampling distribution of p hat look like? So we've got our shape, we've got our mean, and we've got our standard deviation. I'm going to draw a really cool picture here. Let's clear it out. So here's what we've got. We've got a normal probability distribution. We have a mean, mu sub p hat, of 0.62, and we have a standard deviation of p hat, which is approximately 0.04. And I'll explain later why I am using that approximation symbol there. But the next thing that I want is the picture. So what I'm going to draw is a really important picture, and it's a picture that I want you to be comfortable drawing. So I'm going to draw a nice normal distribution here. And remember me keep bugging you guys about labeling this with the correct variable? Here's why. What's the variable that we're drawing the picture of here? This is p hat. Pardon me. So, as I've said several times, is that we've got multiple variables now, and we're drawing pictures like this for a variety of variables. Initially, we started drawing this and labeling it as x. And then at some point we talked about the standard normal, and we labeled this picture with z. In the last lecture, we labeled this with x bar, because we were drawing the probability distribution for x bar. The correct variable here is p hat, and it's absolutely vital for your own sanity that you label this picture with the correct variable. All right, so let's come in here with our mean. Our mean is right here. This is going to be mu sub p hat, and that's our 0.62. And then, of course, with a nice normal distribution, we're going to indicate 1, 2, 3 standard deviations either way. And it's important that you remember that these are increments of 0.04 or 4%. So this is going to be at 0.66, adding 0.04 to that. This is going to be at 0.70, adding 0.04 to that. And this is going to be at 0.74. Subtracting increments of 0.04, this is going to be 0.58. This is going to be 0.54. And this is going to be 0.50. So it's really important that you understand what this picture shows. It shows you what's within reason for values of p hat. Arguably, any value of p hat between 0% and 100% is possible, but that's a theoretical statement. Within reason are values of p hat that are anywhere between 50% and 74%. So if you go to this world where 62% of the people have this characteristic, you take our sample of, what was it, 150 students, you should not freak out if you get a p hat from your sample that's anywhere between 50% and 74%. You get something outside of that range, then there's some explaining to do. Something's not right, and we're going to have to look at it more deeply. So there's our picture, and it's really, really important that you guys can draw these pictures with detail, making sure that the axis is labeled with the correct variable, and 3 standard deviations are indicated each way, right? So this is what I referred to as a detailed picture. And that will come up in the worksheets, the quizzes, not so much in the homework, but when I talk about it, when I ask you guys to draw a detailed picture, this is the type of thing that I'm looking for. Okay, so now what I want to do is ask some questions. Let me erase this, and let me see if I can sneak these questions in over here. No, I'm not going to be able to do it. So, sorry, I'm going to have to erase all of this. But based on this picture, here are some questions that I want to ask. So here's a question. So what's the probability that we get a value of p hat that is greater than 60%. I'm just going to make up that number. The correct notation here to answer this question is going to be, we're looking for the probability that p hat is greater than 0.60. Because we established that we have a normal distribution, I can take this question to our friend normal 83. So let's do this. So via normal 83, and this, what is this type of question? So programs, normal 83, this is a choice number 1. So this is number 1, and normal 83 asks us for the mean. The mean here is going to be mu sub p hat, and remember me bugging you about putting the notation here. Mu sub p hat is 0.62. And again, it's vital that these go in as decimals and not as, like point, or not as 62. The standard deviation here. All right, so let me pause, let me slow down for a second here because this is really important. Sigma sub p hat, I want to know what that is equal to. And just a moment ago, I used the approximation symbol and I said it's approximately 0.04 or 4%. But when I'm working with normal 83, I don't want to put in that approximation. I want to put in the actual calculation. So I'm going to enter the square root of 0.62 times 0.38 divided by our sample size of 150. Normal 83 will allow me to enter that formula, and you don't have to do anything crazy with parentheses or anything like that. When you go and you hit second square root, you can just type it in as 0.62 times 0.38 divided by 150, close the parens, and that'll work just fine. And then our question here, our bounding number is A is 0.60. So let me throw these numbers into normal 83. We said this is a choice number 1. The mean is going to go in as 0.62. Standard deviation is going to be the square root of 0.62 times 0.38 divided by 150. Close parens. I don't know if you all can see that. Enter, and then A is 0.60. And so what I get is a probability of 0.6931. Now I'll put a box around that because that's my final answer. Okay, now if I had the picture, I might go and show the shading in there. But 60%, or 0.60, was a little bit below the mean of 0.62, and this question is about shading all of that area to the right of 0.60. And that corresponds to this probability of 0.6931. And I'll take a look at the picture here. Yeah, there's the shading. That's pretty much what I expected. Okay, so there's a question that we can ask and answer. And once again, I encourage you to do the shading in your own notes. So let me make this go away. Here's another question that we'll put up here, another probability question. I'll ask, would it be unusual to get a value of p hat that is, let's say, less than, oh, I don't know, how about 56%? 6%. Because I think one of the questions that we asked initially about this example was the idea of, hey, what happens if you get a value of p hat of like 56% or something less than that? So that's kind of where I'm going with this question. So here's the answer, is the notation is p hat is less than 0.56. Once again, we have a normal distribution. So I'm going to take this question, I'm going to do it via normal 83. And I believe this is a choice number 2, right? Yeah, it's choice number 2. So this is going to be a number 2. All right, and so it's going to ask me, of course, for the mean, which is going to be mu sub p hat, is our 0.62. It's then going to ask me for the standard deviation, which is sigma sub p hat, which again, I want what that is equal to, not what it's approximately equal to. So this will be our 0.62 times 0.38 divided by 150. And then our bounding number here, normal 83 is going to call it B, and that's going to be the 0.56. So let's take all these numbers, throw them through normal 83. And by the way, you can also do this with the routines that are built into the calculator. This question can also be answered if you know the syntax for normal CDF, which is built into the distributions menu for the calculator. Sorry. So this is going to be a number 2, and we've got 0.62 for our mean. We've got the square root of 0.62 times 0.38 divided by 150. We've got that, and then our bounding number is 0.56. Ooh, it's close. So this comes out to be 0.065. So ultimately, what's the answer to the question is no, right? Because the question was, would it be unusual? And remember that your authors define unusual as 5%. So we're looking at about a 6.5% chance of this happening. So would it be unusual? No. Okay, so you can play around with some other questions here with this distribution, but I want to take you to one more example here, and we'll see how we'll see what happens here. So at this time of year, a lot of people are doing like filing their tax returns, and so let's pull an example from that. So let's suppose that 87.5% of people think the income tax system should be changed. You go and you ask them, hey, you're doing your taxes, what do you think? Is this system good? And you got 87.5% of the people saying, nah, this system it's no good, and we should change it. So what we're going to do is that we're going to take a random sample of, let's say, 50 people. And compute p hat. And again, let's not lose sight of what p hat is. P hat is the percentage of our sample that think this way. Namely, that the system should be changed. All right, so we've got a sample size, we've got a population proportion. Again, remember that that says P is equal to 0.875. Hopefully y'all can see this. Do you understand what that says about Q? Q is going to be 0.125. So remember, if 87.5% feel this way, 12.5% do not. These two percentages have to add up to 1. So that's where I'm getting that value of Q. All right, so here's my first question. We know that P hat is a random variable. Will the sampling distribution of P hat be normal? And we've got those two conditions that have to be met simultaneously. They both have to be met. So I'm going to go and I'm going to check N times P, which will be our sample size of 50 times P is 0.875. So, stuck in normal 83. Now I'm out. So 50 times 0.875, this comes out to be 43.75, which is greater than 10, so everything's cool. We also have to check that N times Q, which is 50 times 0.125. So 50 times 0.125, that comes out to be 6.25. And that is not, so I'm going to use this symbol, greater than 10. So that says we got a problem here. This is a situation where our sample size is not big enough. The sample of 50, if you want to be able to work with this as a normal distribution, you need a bigger sample. So the answer to this question is no. We need a bigger sample. So what do? You stop with this example. We really can't do it. Come back to me when you've got a bigger sample, and then we can have some conversation about this. Okay, so there's the introduction to the sampling distribution for P hat. Hopefully this is making sense. Again, be patient with me. I'm trying to figure out the technology, the format here, come up with something that works. I will, in addition to this video, post a worksheet that you can do, a couple problems that give you some practice with this. Of course, work the homework problems that are assigned. So this wraps up our material for exam 2. And I'll try to figure it out over the next week and a half, figure out how we're going to do exams. So be patient and watch your announcements on Canvas, and we'll go forward from there. All right, be well.